Conduction in non-metals. When one end of the solid is heated, the particles at that end gain kinetic energy and start to vibrate more. In solids, the atoms are tightly packed, so the energy from these vibrations is transferred to neighbouring atoms, causing them to vibrate as well. The transfer of energy happens from atom to atom, but in non-metals, the process is slower compared to metals. Particles in a solid can vibrate in place, but they cannot move around. Conduction in metals. In metals, conduction works differently. The electrons in the metal can break free from their atoms and move around as free electrons. The remaining parts of the atoms become positively charged metal ions. These ions are closely packed and vibrate continually. The more heat applied, the more energy these vibrations have. The free electrons move through the metal, transferring kinetic energy by colliding with the metal ions. This movement of electrons is much faster and more efficient than in non-metals, making metals better heat conductors. In this experiment, a metal bar is heated up. The heat energizes the atoms and vibration increases. The vibration spreads throughout the metal, heating up the entire bar. Investigating heat conductors. To test which metal is the best conductor of heat, you can perform an experiment using thin strips of different metals, for example, iron, aluminium and copper. Wax drawing pins and a Bunsen burner are also needed. 1. Attach a drawing pin to one end of each metal strip using wax. 2. Heat the opposite end of the strip with the Bunsen burner. 3. Measure the time it takes for the wax to melt and for the drawing pin to fall off. 4. The metal that takes the shortest time to melt the wax and drop the pin is the best conductor of heat. Factors that can affect the time include the distance from the flame and the thickness of the metal strip. By controlling these variables, you should find that copper conducts heat better than aluminium, and that aluminium will conduct heat better than iron.